Hi everyone. There's another little piece of info we need before we get too far into working on the trig functions on right triangles, and that's just to mention our special values again. So if you haven't noticed already, I hope you will notice that our special angles, so for example pi over 6, matches up with the nice 30-degree angle if we're working in degrees. Pi over 3 matches up with a 60-degree angle, and pi over 4 matches up with a 45-degree angle. So just like we did before, we want to be really comfortable with running into 30, 60, 45, 90, any of those nice angles. We generally, no, that's not even true. We generally won't see angles bigger than 180 degrees when we're working on triangles. But we will, before the end of the quarter, get to oblique triangles where they do have an angle that's bigger than 90. They can. Okay, so we want to spot these. If we run into a 30, 60, or 45-degree angle, or any multiple of those, we want to be able to say exactly what sine, cosine, tangent, and so on equals. So no approximate, no calculator, we just know. So we want to look back at these triangles again. So this one is a 30, 60, 90. And what's nice with triangles is we don't need to, even in the unit circle, we don't need to think of those as completely disjoint, but especially with triangles, there's no reason to draw one triangle for 30-degree angle and one triangle for 60. This will give us all the information, and we'll just think about it as which side length is opposite which angle and what's the hypotenuse. And then we can also do a 45, 45, 90. Okay, so these are the two triangles we're interested in. And you don't really need to re-memorize anything. It's the same information, but I will point out that usually with right triangle, people memorize the triangle that doesn't have fractions for side lengths. So let me just draw a smaller one first. If we were on the unit circle, sorry, ugly little triangle, and this was our 60-degree angle, that's a pi over 3. So on the unit circle, we know that the hypotenuse was 1, and that the side opposite pi over 3 is a root 3 over 2, and the side adjacent, the x value, is 1/2. And all people generally do for triangles is multiply all of those sides by 3, or I'm sorry, by 2. It's a similar triangle. We have the exact same angles. So this would scale up to be a 2, this would scale up to be a 1, and this would be a square root of 3. So generally, and you don't have to remember a new triangle if you don't want to, but if you'd like to, generally when people start with triangles, they think about it as a 1, 2 square root of 3 triangle. That's the 30, 60, 90. And similar for the 45s, we already know about pi over 4. So if we're at pi over 4, which is the same as 45 degrees, and our hypotenuse is 1, these sides have length 1 over the square root of 2. And both of them are exactly the same. So if we want to scale that one up, we're going to multiply everything by square root of 2 so that we get nice integer, well, not all integer, at least no fractions. So generally when people start with triangles, they'll memorize a 1, 1 square root of 2. It's absolutely not wrong to keep it in your head as 1, 1 over root 2, 1 over root 2, and 1, 1/2 root 3 over 2. Completely correct. So if you just want to stick with your unit circle values, go for it. But I'm imagining that some people have seen these triangles before, and I just want to make sure I made that connection. Thanks for watching.